In this video, we're going to talk about this idea of variable scope and the difference between global variables and local variables. So let's start off by introducing the terms, and we'll take a look at an example here. So a global variable is a variable that is accessible anywhere in the program, and a local variable is a variable that is accessible only within a particular region. And so this idea of scope, is where a variable is accessible. And so a variable is accessible in the block in which it is declared, and a block is like these atomic parts of a program, and in Arduino, it's denoted by these opening and closing curly braces. So if a variable is defined in between an open and a closing curly brace, it no longer exists after that closing curly brace and can't be accessed outside of that block or after that closing curly brace. So an example of that would be if a variable is defined inside of loop, it doesn't continue to exist across the various loop iterations, because what happens is loop is something that runs repeatedly. It runs top to bottom and then it starts back again. So if something is declared inside of loop, it's going to be redeclared every time loop is executed. So if we want to keep track of some value across various iterations of the loop, we need to declare it as global so that its value is only defined once at the beginning, and then it continues to keep track of its value as it maybe increases or decreases over time. So we'll see an example of that here. And so global variables should only be used when necessary, but they are particularly helpful in some Arduino applications. So we'll look at some of those here. So in this example here, it's somewhat contrived, but what we have is we have two variables here. So this first one right here is called global sum, is an integer variable that is set to this initial value of 3. And this is a global variable because it is defined outside of all blocks of code. It's defined outside of curly braces here. So this is a global variable, meaning that it's declared once at the start of the program and it exists over the life cycle of the program. Now right here, this variable called local val that is also set to 3 and declared as an integer variable, this is not global. This is local to the loop here because it's defined in between this open and closing curly brace. So what happens is every time that loop runs, because it runs over and over and over again repeatedly, this variable is recreated and given its initial value of 3. So inside of loop, what happens is we set this value to 3, and then we add local val to the previous value of global sum and store that into global sum. So we're basically continually adding 3 to the global sum. And then what happens is we print out the word local and then the local val, and then we print out global in the value stored inside a global sum. And we can see over here in the serial monitor those values that are printed out. So what happens is local always prints 3 because, like I said, this is a local variable. It's going to get redeclared each time as this initial value. So even if we were to change it somewhere inside of this program, at the very top it would just get redeclared again as 3. But global sum will keep its value. It will maintain its value across these various executions of loop, where loop runs from top to bottom and then goes back up to the top again, because it is declared as a global variable. So it is some value of 3 to begin with, but then we add local val to it. So it becomes 6 the first time it is printed out, and then it becomes 9 and 12 because the local is added to it each time, and local stays at that value of 3. So it just continually prints those increasing values over and over again. So this is how we can keep track of some value over multiple loop executions. So let's take a look at a more practical example here, and a less contrived example. So over here I have a servo motor, and it is wired up to 5 volts and ground, just like we've talked about before, where the brown wire goes to ground, the red wire goes to 5 volts, and then the orange wire is the control pin, which should just go to some digital pin, and I have it here wired to pin 2. And remember, if you have a larger servo motor or multiple servo motors, you typically want to power it from an external power supply, not just directly from the Arduino 5 volts. But in this case, because it's small, I'm pretty safe. So I'm going to go over here to the code, and I'm going to start to define this the way that we've done it before. So the first thing we need to do is include the servo library. So that looks something like this, where I say include servo.h. And then what I'll do is I will define the pin where the servo is connected. So I'll say pound define servo pin, and we connected it to pin 2 there. And then I need to declare the servo object. And so we've just been calling it typically my servo like this. And that's what we need there. So inside of setup, what I'll do is I'll configure the serial port by saying serial.begin 9600 so that we can print out values if we need to check them out to see what they are. And then I also need to set up the servo. And so that is my servo, which is the name of my servo object here, dot attach. And then I need to tell it what pin it's connected to. So I've defined the pin number as this alias servo pin, like that, and then a semicolon. So that's what I need here inside of setup to set up and configure my serial port and my servo. If I want to set it to some initial angle, what I can do is I can say my servo.write, and then inside of the parentheses, it wants just some angle between 0 and 180 where I want that servo motor to be positioned. So I'm going to tell it to start at 0, and I'm going to give it a bit of a delay so that it will get to that position and kind of stop. So have it go to 0, wait 2 seconds before it goes on to loop, which will run over and over and over again. So if we want to just kind of see it move and make sure that it works, let's do this. My servo.write, and we'll tell it to go to 180, basically the other extreme, and then we'll tell it to wait for 1 second, and then we'll tell it to go back to 0, and then wait for another second, or 1000 milliseconds there. And let's upload this program and make sure that we've wired everything up correctly and that it works. So it should go from 0 to 180 to 0 to 180. So there we go. So it's kind of flip-flopping back and forth every second. And we can see it's not quite going a full 180 degrees. This is a pretty cheap servo, so that's likely why. But it's kind of working the way that we want it to. So when we just tell it to write to some position, if we're doing it at a position that's 180 degrees away and then just telling our program to wait, it's trying to get there as fast as it possibly can. So we have no real control over the speed at which something's happening. And maybe we're trying to control some robotic arm or something that we maybe want to move a little bit slower. And so that's a good candidate for using a global variable to try and more, to dial in the speed a little bit better. So I'm just gonna unplug this for a second so that it stops making sound, and we're gonna go back to our code and take a look at this. So if we wanted to better dial in the speed, what I could do is I could do something like this, where I could say, all right, well, let's try and have it go 1 degree at a time. So I could say, okay, start at 180. Actually, wait, we're starting at 0 here. So let me backtrack real quick, right? So if it starts at 0, then I could say, okay, well, let's have it go to 1 and then wait 10 milliseconds. And then I could say have it go to 2 and then wait 10 milliseconds and then 3 and so on. But I would have to copy and paste this 180 times for it to go from 0 to 180, and then 180 more times for it to go from 180 to 0, where this would make it move a little bit slower as it goes 1 degree at a time at a slower rate. So this is what we want, but we want to do it in a more efficient way through code. And so our best way of doing this would be to create a global variable to represent the angle where our servo should be positioned at, right? So let's first start by creating it as a local variable and then talk about the issues with that. So I could create some integer variable to represent the angle, and I'll call it angle and start it at 0. And then what I could do is I could say write the position, and that position would be represented by my variable angle. And then I could have it wait 10 milliseconds. And then what I could do is I could take the value of angle and I could add 1 to it like this. I could say, all right, let's take angle, add 1 to it, and store it back into angle. A shorthand way of doing this that is available in a lot of programming languages is something that looks like this, where you say angle plus plus, which is the exact same as doing this, as just slightly shorter. And so I'm going to leave this here kind of as a comment to describe what that's doing. But saying angle plus plus is just a shorthand of saying add 1 to that previous value or increment that value. Okay, so if I upload this program, and I need to go back over here and plug this into 2. we just see that it stays right there. It's stuck right there, and we could better see what's going on if we wanted to by, let's print the value of angle to the serial monitor like this. So let me upload this again. And once it's done uploading, what I will do is I will pull up the serial monitor by hitting this magnifying glass, and we can check the value. There it is. So it's just consistently a value of 1. And so the reason for that is we declare this variable to be 0. We say myservo.write angle, so that would be writing it to a value of 0. Then we wait 10 milliseconds. Then we're adding 1 to that value, and then we are printing out that value of 1. But then when we go back again and loop executes again, this value gets redeclared as 0. So that's why it's always printing a value of 1. It is continually adding 1 to it, but it's getting redeclared each time as 0 because this is a local variable. It is defined in between the open and closing curly braces associated with the loop. So if I want to make this a global variable, what I'm going to do is I'm going to copy this and I'm going to put it up here at the top. And now it's defined outside of all of my blocks or outside of all of my curly braces. So it's defined at the beginning as 0. And then it should continue to update over time here. So let's upload it and let's make sure that our motor starts to move here, and we'll see that our values will change. So here it goes. There we go. So it happens to go beyond 180, and then we'll start to get some weird behavior because we're really just supposed to write values between 0 and 180. But we can take a look at how we could fix that, right? So what we could do here is say, all right, if it goes beyond a value of 180, like this, so we could say if angle equals 180, what we can do is say, all right, now we want it to decrease. And I think the best way of doing this would be to create another global variable. And so what I'm going to do is I'm going to declare a global variable that is a Boolean value, either being true or false. And, or I guess you can just call it a bool. And I'm going to call this increasing and set it equal to true. And what this is going to represent is if our angle is increasing, it'll be true. And if our angle is decreasing, it will be false. So once our angle gets to 180, what we'll want to do is we'll say, let's set increasing equal to false. So that what we can do is now start to subtract from it as opposed to add to it. So I'm actually going to copy this down to here, or wait. Yeah, that works. We'll just leave it there. And then here what we can say is we'll have another condition that says else if the angle is equal to 0, meaning that we're getting all the way back down to 0 again, we will change this to be true and make it increase again. So this is the first part, is just setting up the conditions under which we want to increase and when we want to decrease. And then what we'll do is we'll modify when we are adding 1 to this value or when we are subtracting 1 from this value. So we can say if increasing, which is just a fancy way of saying use the Boolean variable increasing as our true false, our condition for our if statement. So if increasing is equal to true, what we want to do is add 1 to the angle, which is this line of code right here. So I'll just cut this and I will paste it right there. Then we can have our else condition here to say else if increasing is false, let's do the opposite of this. Let's subtract 1. And so the shorthand way of doing that, you could probably guess it, is angle and then minus minus, which is the same as saying angle equals angle minus 1. So it's a little bit more complicated now. There's just some conditional statements inside of here, some if statements, but it should basically start at 0, go up to 180, then go back down to 0, then go up to 180, and all over and over and over again. Because what happens is our angle starts at 0 at the beginning, and we start off by increasing. And so it would write that angle of 0, delay for 10 seconds, and then say, If increasing, which is true, add 1 to it. And then it prints the angle, and then it will only change whether it's increasing or decreasing if that value is 180 or 0. So let's upload this and make sure that it works the way that we expect it to. I guess we should show our serial monitor here. There we go. So now it's going up and down and up and down. So this is a very useful example of when to use a global variable so that we can better control the speed of this motor, right? So if I wanted to speed it up or slow it down, I can just change this delay value. So if I want to slow it down pretty substantially, I could change this to be 50, upload my new program, and see it go a lot quicker, or sorry, a lot slower, because it's waiting 50 milliseconds between each degree. So there, it's kind of creeping along much slower. But if I wanted to see it go a lot faster, I could change that delay to something like 1, and that might not even be enough time for it to get to that next degree, but we'll see what happens. Yeah, there we go. So it's moving a lot faster now. All right, so this is a very useful example of when to use a global variable.